Hello, Matthews Gatos here. Welcome to Chapter 7, Lesson number 3, Simplifying Rational Expressions. Before we start talking about how do we simplify rational expressions, let's go back to something we all can visualize, which is numbers. So when you guys were first dealing with fractions, we always told you to put them in lowest terms. Well, what that means is that I don't want the numerator or the denominator to have a common factor other than 1. So for example, 5 over 10. That is not simplified because 5 and 10 have a greatest common factor of 5. So I can simplify that further. I could divide the numerator by 5 and divide the denominator by 5 to get 1 over 2. 1 over 2 is simplified because the GCF of 1 and 2 is just 1. So we want to take this idea and put it forward to fractions with variables in them. We always want it to be in simplest form, meaning the numerator and denominator have no common factor other than 1. So there's two types of fractions we're going to deal with, monomials and binomials. So this isn't in your workbook, but I want to go over this and it's worth writing down. When we have monomials, what I want you to do is line up your terms together. So see how I have numbers and then x and then y? I want you to line it up like that because then it's super easy to divide. Once I've done that, I want to state my non-permissible values. So those are the values that make the denominator equal to 0. So looking at the bottom, my denominator, I have a monomial, and monomials always have restriction that variable can't equal 0. So x and y can't be 0. Now we're ready to simplify. So I want to divide my numbers with my numbers. So 10 over 15. Well, I know that has a GCF of 5, so I can divide each by 5 to get the answer to be 2 over 3. 10 divided by 5 is 2, 15 divided by 5 is 3. Or your graphing calculator can help you with the numbers. So what you can do is use your math fraction button on your calculator. So I enter in 10 over 15, I go math, frac, enter, and I get 2/3. So you can do it with GCF or you can use your math frac button. Now let's do our x's. We have 2 on top, 1 on bottom. So I have more on top, and 2 take away 1, I have 1 more on top. Let's look at our y's. I have more on the bottom, and I have 5 take away 3, 2 more on the bottom. So you can leave your answer like that, or you don't really need the exponent of 1 for the x. You can just write it as 2x over 3y squared. So that's the first type of fractions that we'll have is when they are dealing with just monomials. The other type we can have is binomials. So this is an example where I have a binomial in the numerator and a monomial in the denominator. So with binomials, what you want to do is factor. So I'm going to factor the numerator, and if that factor goes into the denominator, I'm also going to factor the denominator, even though it's a monomial. Then we're going to state our non-permissible values and cancel common factors, not common terms. Okay, so again, in the denominator, I have a monomial, so my restriction is x can't be 0, variable can't be 0. In the numerator, I'm going to look at my numbers, and I'm going to look for the GCF. So the GCF of 15 and 5 is 5. So I'm going to factor out of 5. I notice they both have x's, so I go to the smaller of the two, which is just x to the 1. So my GCF is 5x. So I'm going to factor that out. So 15 divided by 3 is, 15 divided by 5 is 3. X cubed divided by x is x squared minus 5 divided by 5 is 1. X divided by x also 1. Now what I'm going to do to make this a little easier on myself is see, can I factor out a 5x from the denominator as well? Because then they can cancel. And I actually can. 15 divided by 5 is 3, and x cubed divided by x is x squared, because 3 take away 1 is 2. Okay, so now I have common factor of 5x, and my final answer is going to be 3x squared minus 1 over 3x squared. Can I then cancel this and say that my answer is -1? Well, no, because I cancel common factors, not common terms. So this is not a 3x squared in the numerator, it's a 3x squared minus 1. It's all attached. So that is as far as I can go. Okay, so let's try some examples. I want to express these rational expressions in simplest form, stating the non-permissible values as restrictions. So again, as I said before, if you have a monomial in the denominator, it will always have a restriction. Variable can't be 0. Okay, if you have binomials, the restriction is going to be the opposite signs of the factors. So +7, -7, +1, -1. Okay, so now that we're done with our restrictions, let's go ahead and simplify. So in the first one, I have monomial over monomial. So I just divide 12 by 2 to get 6, and x squared divided by x to be x. 2 on top, 2 take away 1 is 1 left over. Okay, in the next example for B, it's already been factored for me, so I look for common factors like the a plus 1. So this simplifies to be a minus 6 over a plus 7. I cannot cancel those a's because those are not factors, they are terms. So that a in the numerator is attached to the minus 6, and that a in the denominator is attached to a plus 7. So you cannot cancel. Okay, and this one here, 8y and 2. Well, that has a GCF of 2. So I'm going to factor that out. So 8 divided by 2 is 4, and I'm left with a y, plus 2 divided by 2 is 1. Now, because I have a monomial in the denominator, I'm going to check to see, can I take a 2 out of the denominator? And I can. 8y divided by 2 is 4y. So I write it like that because then it's easier to simplify. So 2 divided by 2 is 1. I'm left with 4y plus 1 over 4y. Again, I cannot cancel those 4y's because in the numerator, it's not a 4y, it's a 4y plus 1. Okay, let's try another one. So I want to factor the numerator, factor the denominator, state the restrictions. So for these ones here, 49 minus x squared, I'm actually going to do my non-permissible values in my calculator. So I put it into my calculator and I look for the x-intercepts because the x-intercepts of the denominator are the non-permissible values of the whole fraction, and I can see that x cannot be positive or -7. So in the numerator, nothing to factor. In the denominator, this is a difference of squares because the square root of 49 is 7 and the square root of x squared is x. So square root of 49 is 7, so I put the 7 first. Even though I really want the x first, you have to go in the order that they have it. Square root of x squared is x, and then I add one set and subtract the other. So I can see here that x plus 7 and x plus 7, it's just backwards here, same terms, same signs, cancel, and you're left with a 1 in the numerator over 7 minus x. You can always check this on the calculator just to see if you're right, because that question was a little bit different. I put the question in y1, my answer in y2. Remember, the check always happens in the table, and I can see that they're equal, so I know I simplified correctly. So this unit especially, your calculator is really going to be your best friend. Okay, let's try this one here. So for this one here, I'm going to again do my non-permissible values, my restrictions on the calculator. So I'm going to put the entire denominator into my calculator, and I'm going to look for the x-intercepts. So x-intercepts of the denominator are the restrictions of the entire fraction. So I can see that I have restrictions of 0 and 2/3. Okay, so let's look in the numerator. So in the numerator, 12 and 8 have a greatest common factor of 4. P squared and P have a greatest common factor of P. So let's divide that. 12 divided by 4 is 3. P squared divided by P is P. Take away. 8 divided by 4 is 2. P divided by P is 1. Okay, in the denominator, 6 and 4 have a greatest common factor of 2. P cubed and P squared, I'm going to go with the smaller of the two, which is P squared. So 6 divided by 2 is 3. P cubed divided by P squared is P, because 3 take away 2 is 1. Take away, 4 divided by 2 is 2. P squared divided by P squared is 1. So I can see what I end up with here. This cancels and this cancels. And then what I'm left with is really a monomial over a monomial. So I'm going to use my rules of monomials to simplify this a little bit further. So in the numerator, let's focus on the numbers first. 4 divided by 2 is 2. And then look at your p's. P on the top, 2 p's on the bottom. There's more p's on the bottom. And 2 take away the 1 that I have there. I'm left with 1. So you can say 2 over p to the 1 or just 2 over p. That would be my final answer. Again, you can always check on the calculator. Original question in Y1, answer in Y2. The check always happens in the table, and since they are equal, I know I did that correctly. Okay, for this one here, so looking at these ones here, it's already factored in the denominator, so my non-permissible values are just the opposite signs of the factors. So the opposite of a +3 is a -3, and the opposite of a -5 is a +5. Okay, so in the numerator, the denominator is already factored, so I can just leave it like that. In the numerator, let's take that to the side here and factor that. So between 3 and 75, I know I have a GCF of 3. So 3 divided by 3 is 1, so I'm just left with t squared, minus 75 divided by 3 is 25. So keep the 3 there. Now this is a difference of squares because the square root of t squared is t, and the square root of 25 is 5. So square root of t squared, t is first, and square root of 25, 5 is second. Add one set, subtract the other, doesn't matter the order. So 3 times t plus 5, t minus 5. And then I look for common terms, and I can see t minus 5 is common to both. So I'm left with 3 times t plus 5 over t plus 3. Again, big fan of the check. Original in Y1, answer in Y2, check always happens in the table, and I see it Y1 equals Y2, so I know that I have done this one correctly. Okay, let's look at a little shortcut which is going to come up from time to time. If we have something like this, and we saw this on the other question, if I go back over here, which one was it? It was, I just want to show you, this one here. Remember on this question here, it was x plus 7 and 7 plus x. So they were the exact same terms, positive x, positive x, positive 7, positive 7. So the first shortcut is like this. If I have it a little bit backwards, a plus b and b plus a. So really I have the same terms and the same sign. So a and positive a, positive b and positive b. That simplifies to be -1. Now, that's not true for subtracting. They're not identical. But if you look at this, if I had A minus B, and then I flip it around and B minus A, those are not the same thing. They are the same terms, but they are opposite signs. So see A and -A, -B and B. So since they are same but opposite, they don't cancel or simplify to be 1. They simplify to be a -1. Now, where do you put that -1? Question I get asked a lot, you put it in the numerator. The reason is because if we leave it in the denominator, we might forget about it. So always put it in the numerator. So let's try an example where we're going to use that. So if I have c minus 4 over 4 minus c, first of all, I want to look at what value of c makes the denominator 0. So 4 take away 4 is 0. So c can't equal 4. So see here how I'm the same but opposite, c and -c, -4 and +4. I am same but opposite. So to show that they are opposites of one another, it simplifies to be -1. Now sometimes it's not that simple, sometimes it's within the factoring. So if you look at this one here, let's go ahead and factor this. So in the numerator, I have a GCF for the numbers of 2 and for the variables p squared. So 2 divided by 2 is 1. P cubed divided by p squared is p. Take away. 4 divided by 2 is 2. P squared divided by p squared is 1. In the denominator, 16 and 8 have a greatest common factor of 8. So 16 divided by 8 is 2. Take away. 8 divided by 8 is 1, and I'm left with the p. So doing the restrictions, here, no variable, no restriction. Here, 2 take away 2 would cause the denominator to be 0, so p can't be 2. Okay, so looking at this here, notice I have p minus 2 and 2 minus p. Same but opposite. So these cancel to be a -1, and I put the negative in the numerator. So what I'm left with is -2p squared over 8. And I just have to simplify my numbers. So this is an example of where I can use that math frac, or I can see they have a GCF of 2. Either way you want to, final answer is going to be -p squared all over 4. So 2 over 8 in lowest terms is 1 out of 4. Okay, let's try a little word problem here. So the area in meters squared of a rectangular plot can be represented by the expression x plus 6 all squared. The length in meters of the plot is represented by x squared minus 36. I want to write and simplify a rational expression that represents the width of the plot. So what I did on the side here is I wrote out what area is. I know area is length times width. Well, since I want an expression for the width of the plot, since I multiplied width by length, I divided both sides by length. So width is really the same as the area divided by the length. So I'm going to use that. Width is area divided by the length. So we were told that the area is x plus 6 all squared, and the length was represented by x squared minus 36. So I want to simplify this. So x plus 6 squared, I like to write that out twice. That just means a binomial multiplied by itself twice. X squared minus 36 is a difference of squares because the square root of x squared is x, and the square root of 36 is 6, and it's subtracted. So square root of x squared, x is first. Square root of 36, 36 is second. Add one set, subtract the other. And then you can see common factor of x plus 6. So it simplifies to be x plus 6 over x minus 6. That would be the expression for the width. Let's try continuing with that. If the length of the plot, so the area is x plus 6 squared, the length is still x squared minus 36. If the length of a plot is 28 meters, determine the value of x if x is greater than 0. So the length of the plot, okay, well the length is x squared minus 36. And I know that if the length is 28, we want to determine the value of x. So if the length is 28, I want to solve for the value of x. Okay, so I have x squared minus 36. So what I'm going to do is I'm going to add 36 to both sides to get x squared by itself. So that's gone. So 28 plus 36 is 64. And then I take the square root of both sides. Because it is length, I'm only looking for a positive value. So x is equal to 8 meters. So the length is 8 meters. And even here they said x is greater than 0. You can't have a negative length. So x can't be -8. It is, in fact, +8. Okay, so now if we're told that this plot has to be treated with fertilizer at a cost of $2.40 per meter, what is the cost? Well, now we know the value of our variable x is 8. We want to figure out what the area of the rectangular plot is so that we can figure out the cost. So the area is x plus 6 all squared. So if x is 8, I'm going to have 8 plus 6 squared. So 8 plus 6 is 14 squared, and 14 squared is 196 meters squared. So the cost is $2.40 per square meter, which means I am going to take my area and multiply it by $2.40. So let's go ahead and do that. We're going to do $2.40 multiplied by my area. That will give me my total cost. So multiply by 240, and I get $470.40 would be the cost of the fertilizer. Okay, to summarize our lesson, you want to simplify monomials with monomials by using the quotient law. binomials by binomials by factoring. You can't cancel a monomial and a binomial, so you're only looking for common factors, not common terms. And remember to always state your restrictions before you simplify. So simplifying is really the key, such as this student who doesn't celebrate Valentine's Day on 2/14, February 14th, he celebrates it on 1/7 or January 7th because he knows how to simplify fractions. Get it? Cute little joke. Okay, you guys can work on your assignment in your workbook, numbers 1 to 8. I hope this video helped, and I look forward to seeing you for the next one.